Freedom lying down to make my boo with love and choice mean to be bamboo while we're leaving to make and do well living so well to will till
Now let's find the derivative of sine 2x. So f prime of x is equal to cosine 2x times the derivative of 2x, which gives us cosine 2x times 2. Now to further simplify this function, f prime of x is simply equal to 2 times cosine 2x. And this is how we use the product rule for simple trig functions like sine 2x. Now let's find the derivative of cosine 3x squared minus 1. We are still going to use the product rule for this example. So let's find the derivative of cosine 3x squared minus 1. Therefore, the derivative of cosine 3x squared minus 1 is negative 6x sine 3x squared minus 1. Now I want you to find the derivative of these two trig functions using the product rule. So for number 1, your answer should be 2x times secant squared x squared minus 1. And for the function cosecant e to the 3x, the derivative of g of x will be negative 3e to the 3x times cosecant e to the 3x times cotangent e to the 3x. So let's find the derivative of x squared plus 1 times the cube root of x squared plus 2. So before I start using the product rule for this function, I will change my second factor into an exponential function to make it a lot easier for me to derive a of x. It's a lot easier to use the derivative rule when your factor is in exponential form. Therefore, a of x can be simplified into x squared plus 1 times x squared plus 2 raised to 1/3. Now I'm going to use the product rule to derive a of x. So I'm going to copy the first factor, which is x squared plus 1, and multiply it with the derivative of x squared plus 2 raised to 1/3 using the chain rule. And it will look something like this. So let's further simplify the derivative of a of x. Therefore, a prime of x is equal to this function. Once again, a of x is an example of a function wherein you need to use two rules to be able to find the derivative of this function. Now let's try to find the derivative of this second example. I'm going to give you a few minutes to answer this. And if your answer is correct, the derivative of a of x is equal to this function. Or if you want to further simplify a prime of x, you can change the exponential function back to its radical form.